Hi dears, observe this question, very interesting. Before going to that question, better to log in our website for more updates. Okay, what is our target? GATE 2025 30 marks. Be focused. Okay, right. Consider two ordinary differential equations. ODE means ordinary differential equations. It will be very easy to pronounce, right? That's my perception. Okay, fine. P dy by dx is equal to x power 4 plus 3x square y square plus 2y power 4 by x cube y. Okay, fine. Then what about Q? Dy by dx equal to minus y square by x square, right? These are the given differential equations. But here we need to remember one point here. Observe it properly. Dy by dx can be called as what? First order differential equation, right? So what do you mean by order? The power, that's it. Dy by dx can be called as what? First order. If I go for d square y by dx square, d square y by dx square, it can be double derivation, right? For your comfort only, in our local language. Derivation, double derivation will be there. It can be called as what? Power 2, second order. If I have d cube y by dx cube, d cube y by dx cube, it can be called as what? So, cubic or else higher order. Okay, always remember one thing. Whenever you have power 1, it can be called as what? First order or ordinary differential equation. This is a basic idea. He has given two different differential equations. But if you go for the options, whenever we have differential equations of first order, we'll have 5 methods to solve, right? Did you remember or forget? Need not to worry, don't confuse. To solve first order differential equation, we'll have 5 methods. According to those 5 methods, you can get the solutions for this equation, right? This is a basic concept. What do you mean by solution? Solution is nothing but I need to find y value. Y is equal to what? That is the basic concept, right? So don't confuse, very easy. Okay, but here according to the options you can decide. Actually, how many methods will be there? 5 methods. What is that one? First one can be variable and separable. Variable and separable. What do you mean by this? So we need to divide y terms and x terms. This can be called as variable separable. Sorry, it will be discussed later. Don't confuse. Okay, then what about second one? Second one can be homogeneous. Homogeneous method will be there. Don't confuse. Homogeneous differential equation. How to solve differential equation in this method is very important. Next one, third one can be exact differential equations. Right. Then what about last one? Not last one. One more thing is there. That is what? Fourth one, linear differential equations. So fifth one can be Bernoulli. Did you remember Bernoulli? So first one variable separable, second one homogeneous, third one exact, linear, and Bernoulli. These are the 5 methods we have to solve the differential equation of first order. This is a basic concept. But here you need to realize one point. What is that? Actually, what is the question here? Which one of the following options is correct? Okay, we need to verify the options only. But according to options, you can go to the method, right? So according to given options, we need to connect to the particular method. That is a basic concept. Fine. What is our option A? Option A is P is homogeneous. ODE means what? Same. Upside will have pronunciation, don't confuse. And Q is an exact ODE. Okay. Homogeneous and exact. He is mentioning 2 methods. Homogeneous and exact. Okay, fine. Next, option B. P is homogeneous ODE and Q is not an exact. Okay, fine. Again, he is mentioning only homogeneous and exact only. Fine. Next, C. P is non-homogeneous and Q is an exact. Again, he is mentioning homogeneous and non-homogeneous only, right? So logically, we need to verify homogeneous and as well as exact conditions. That's it. Nothing is there. But then what about D? P is non-homogeneous and Q is not an exact. So fine. So we need to go for only these 2 methods. We need to verify these 2 methods. That's it. If 2 equations are matching with the homogeneous method and exact method, happily we can select the options according to the given story. Right? This is a basic concept. I don't want variable separable as well as linear and also Bernoulli. Right? Okay. According to this question, I can go for these two methods. What are those? Homogeneous and exact. Right? Yes, first one, homogeneous. We need to verify P. Always he is mentioning P value with respect to homogeneous, right? Observe clearly, whenever you have differential equation like this, what do you mean by homogeneous equation? Very simple, degree should be matched, right? Observe it clearly. P x power 4, x square, y power 4, x cube, y power 1. Of course, x cube, y power 1 is there. Power 4, power 4, power 4. Yes, degrees are matching, right? Upside powers will be. The highest power can be 4, right? Power 4. Yes, 2 plus 2 will be power 4. Y power 4. Of course, x cube plus y power 1 will be power 4 only. Sum of two factors. But degrees are matching. But it is not homogeneous. It can be non-homogeneous option. Why? How can you consider it? Always remember one point. Observe every term. It may be upside or downside. Observe every term. X power 4 is there. Fine. Here will have y. Y power also 4. Yes. The powers of x and y should be matched. Then only it is called homogeneous equation. Okay, fine. Here x square is there, y time also is there, x power 2 is there, y power 2 is there. Yes, upside values are matching. X power 4, y power 4, good. X square and also y square matching. And what about this one? X cube is there. Beside that we'll have y power 1 only. That's why it cannot be homogeneous equation. Basic concept. It cannot be homogeneous equation. Okay, if you have homogeneous equation, how can we solve this equation? Of course, we'll have so many ways, need not to worry. Okay, according to the given option, I can eliminate A and as well as B. Why? Because P is homogeneous, P is homogeneous. He is mentioning A and B as homogeneous equations. Logically, it cannot be homogeneous, it can be non-homogeneous. That's why I can go for only C and D options. A and B eliminated, right? Okay, fine. So, what do you mean by homogeneous? X terms power should be matched with y power, y terms power. Basic idea, don't confuse. X power, y power is matching. X square and y square is matching. X power 3, y power 1 is there. That's why it is not homogeneous equation. What is homogeneous equation? In each term, x power value should be matched with the y power value. Then only it is called homogeneous equation. Okay, for an example, if I take one more example here, don't confuse. Here x minus y is there, x plus y is there. That is this is dy by dx value. According to the given option. Dy by dx value can be what? X minus y by x plus y. Observe it clearly. What is x power 1? X power 1 is there, right? Whatever y? X power 1, y power 1. X power 1, y power 1. Logically, the powers of x and y terms are matching. That's why it can be called as homogeneous. Then how to solve homogeneous equation? Of course, we'll have process. The process is very important for your comfort only, but need not to discuss. It will be discussed in our basic classes. Don't confuse. Whenever you have homogeneous concept, okay, y is equal to vx we need to take, right? Y equal to vx we need to take. This is a basic procedure actually. Okay, fine. What is dy by dx value? Dy by dx is nothing but d by dx of, be careful, d by dx of with respect to x of vx is there. Okay, whenever you have two terms, product of two terms, did you remember? Product of two terms, d by dx of uv, u v dash plus v u dash. This is the basic idea, right? Whenever a product of two terms, logically we can split like this: v d by dx of x only, right? Plus x dv by dx. This is the process actually. Don't confuse, all of you. Okay, fine. If you go for d by dx of x, it can be 1, right? Basic rules. D by dx of x can be 1. Fine. So v plus x dv by dx can be called as what? dy by dx. This is a basic idea. dy by dx will be v plus x dy by dx, right? So in the place of dy by dx, we can replace this total value, right? Simple concept. Fine. In the place of dy by dx, it can be replaced by v plus, come on, v plus x dv by dx is equal to, in the place of y, we need to replace vx value. Simple concept. So x minus vx, in the place of y, we can replace vx. Fine. Divided by x plus, again vx. Same concept. Okay, after getting the values in x and v, we need to split. Okay, dv should be, this dv can be for what? V values. This dx can be what? For x values. That is a basic concept. Fine. Upside we can take x common, right? X common, come on, x common. 1 minus v by, downside will be 1 plus v, of course. X get cancelled, but we'll have, don't confuse. V plus x dv by dx is there, right? Not dy, dv. Be careful. dv by dx will be there. V should be here. Again, we can simplify it. After getting v values one side for your comfort only. V values with respect to dv. We'll get one more term, that is what x value with respect to some dx, some x into dx. After getting these dv values, we need to apply integration. So we need to apply integration for individual variable separable differentiations. So dv with respect to v terms, dx with respect to x terms. So we can apply the integration. This is a basic concept of what, how to solve homogeneous equation, right? But I need not to calculate these total values for your comfort only, right? What is the process we have? So we need to observe the particular equation degree value. So we need to understand the powers. X power 4 is there, x square is there, of course. According to the given situation, x powers should be matched with the y powers, y terms powers. In that case, happily we can decide it can be the homogeneous equation, right? But according to the given options, given question, it is not homogeneous equation. If it is homogeneous equation like this, happily you can utilize this one, y equal to vx. After substituting, at the end of the story, we'll have v values, right? In the place of v value, what we can put? In the place of v value, what we can put? In the place of v value, after final touch, after solving the equations, we can get v values only. In that v values, happily you can replace v is equal to y by x. That's it. This can be the final step of what? Homogeneous equation. This is the basic process. Y equal to vx. Nothing is there, right? Don't confuse me. Fine. According to the situation, happily we can deal the answers, but it will be discussed in basic level classes. Don't miss the basic level classes. Differential equations topic is there. Better to watch all those videos. Then you can get good comment. Fine. This is a story of what? The story of what? P. Logically, I can eliminate A and B options. Why? Because P is homogeneous, B also P is homogeneous. That's why eliminate two options. If I go for C, P is non-homogeneous. Of course, it is not non-homogeneous. Then what about D? D also. P is non-homogeneous. Matching. Two options are matching, right? But I need to verify Q also. Option C. Q is an exact ODE. Fine. Option D. Is not an exact, Q is not an exact ODE. Fine. I need to go for Q equation again. But I need to go for Q equation with respect to exact condition. This can be homogeneous. P can be homogeneous condition. It's proved that it is not an homogeneous equation. That's why it can be non-homogeneous. Fine. If I go for Q, don't confuse. Now we can go for Q. So according to the given situation, P equation is non-homogeneous. That's why eliminate A and as well as B options, right? Those should be eliminated. Now we can go for C and D. What is the purpose of C and D here? We have P is non-homogeneous, correct, but Q is an exact. Maybe it may be different story. It may not be exact, right? There is a chance. That's why I can go for verification of Q in exact process, right? What is the process we have for exact? Very simple. Don't confuse all of you. The situation should be like this. M of, we may have x and y terms also. There is a chance. We don't want. Plus n of, there will be x and y terms also. Those should be equated to 0. After equating 0, we may have x terms and y terms also, right? Of course, here we will have only single terms. That is the differentiation. M of xy is there, n of xy is there. So, but I need to verify only one condition. What is that? Dou m with respect to dou y we need to verify. But the equation should be in the form of this one, right? But we can consider, don't confuse. That should be equated to dou n by with respect to dou x. This is the basic verification we should have. After verifying this one, you can get a solution for sure for this equation. You can go for this equation. Fine. Let's start. Here, just bring this value this side. Come on. We need to arrange this equation in this form, right? Yes or no? Very simple. Come on. X square into dy is equal to minus y square into dx. Of course, dx should be multiplied to this side. It can be dx. But we need to bring this value this side to get an equation like this, right? Simple concept. Don't confuse. Very simple. X square dy plus y square dx is equated to 0, right? Yes, I got the equation in the form of this one. And what we need to find actually? We need to find dou m by dou y values. It can be m. That's it. Okay, apply it. N equal x square. I need to find dou m by dou y with respect to y. With respect to y. Dou m by dou y. Come on. Dou m by dou y means dou m by dou y of y square can be what? Can be what? 2y. That's it. Then what about dou n? So dou n by dou with respect to x. N means what? We can replace here x square, right? So it is also 2x. But logically it is 2y. It can be 2x. That's why dou m by, be careful, dou m by dou x is not matching. Dou m by dou y is not equal to dou n by dou x. That's why it is not an exact differential equation. I mean, we cannot get the answer by utilizing exact differential equation condition, right? If there is a chance of dou m by dou y is equal to dou n by dou x, then there is a chance. Of course, same, we can apply variable separable process, we can get the answer for sure. This is a basic idea. So final conclusion is what? Don't confuse. So according to the given situation, we need to go for exact method, right? To get the answers in exact method, we should have one condition. We need to verify dou m by dou y is equal to dou n by dou x. So logically, whenever we have x terms, apply derivation with respect to x. Whenever we have y terms, apply derivation with respect to y terms. But dou x by dou m by dou x, whatever, dou with respect to x, derivation value should be equal to with respect to y, derivation value. But logically, dou m by dou y is equal to y, but dou m by dou x is not equal to dou n by dou x, right? That is a basic idea. That's why finally, so answer can be, it is not an exact ODE. Clear? So that's why the best option is what? D. D can be the best option. Option D. P is non-homogeneous. Yes, it's proved. Q is also not an exact ODE. It's clearly showing that A, B, C eliminated. D is our option. So better to go for the basic level videos, man. Don't miss basic level videos.